let us take another problem on AC circuit. And this is a AC parallel circuit. In this, you see the circuit is given and it is asked to find out the current in each branch and also the power consumed in the circuit and the power factor. And we'll draw the phasor diagram also. Now you can see that in one branch, it is a RL circuit, the resistance and inductance. In other branch, it is an RC circuit. And it is been supplied with a AC voltage where is 200 is the RMS voltage and with the 50 Hertz. And now we'll find the current in this. Let us take here, I have shown here I have redrawn the circuit again. That this is the main current and these are the branch current. I1 and I2 are the branch current. Now first we find out the impedance in this branch number 1. That means ACB. What is the impedance of that? Now for that we have to find the inductive reactance. Then we know the real part is the R1 and we'll find the inductive reactance, and we found that as we know that inductive reactance is the imaginary part, and we'll substitute that, and we found Z1 is 10 plus J 37.68. Now we come to the ADB branch, that means this branch. Now here again it is resistance is the real part, therefore 20, and we found the and the negative part is the capacitive reactance. Therefore we found that Z2 found to be this after calculations. Then we will find the equivalent impedance. That means Z1 and Z2 equivalent impedance. The formula is exactly same like that of how we find in the DC circuit, how R1 into R2 divided by R1 plus R2. Here also it is equivalent impedance Z is equal to Z1 into Z2, Z1 plus Z2. But here calculation has to be made. You can see that there are this is the Z1, this is the Z2, this has to be multiplied. Therefore this is just a simplification in a complex algebra mathematics. Therefore you can see a real part 200 and this is 796.2, and only thing is that wherever J square will be there, therefore wherever J square will be there, that will be replaced by -1. That is the only thing. And then we got that after the calculation we got it. That you can see denominator and numerator are both in the rectangular form. That will bring it to polar form, and the polar form, after polar form, you know that magnitudes will be divided and the angles phase is to be subtracted. After that we got this value of equivalent impedance. After finding the equivalent impedance, the main current I can find the voltage divided by equivalent impedance. Therefore that only we are doing here. Therefore, and voltage we are taking a reference with the angle as a reference. Therefore it is 0 degree, and divided by Z we are finding this is the magnitude and this is the phase angle. Therefore in this case you can see the current is lagging behind the voltage. Therefore the equivalent circuit is an inductive circuit. That I wanted to mention here. And then I1 you can find that because the potential difference, it's just like a DC circuit, potential difference between A and B is the same as 200, and then this potential difference divided by Z1 will give you the I1, Therefore, I1 is V divided by Z1, and that we found that in the polar form. And I2 also exactly in the similar, we divided by Z2, we found that. But one thing you mentioned, that is a very big difference with the DC circuit, that you can see magnitude of I is 3.22, but I1 is more than that. That is why I just wanted to show in the vector diagram. That is, it will be clarified in the vector diagram. And this is therefore I is not the algebraic summation of it is a vector summations. Now after that we'll see that what is the power factor. Power factor is the angle cos of the angle between voltage and the current. Therefore it is a 53.65, and because the current is lagging, therefore I just bracket I put the lag. And power consumed Vi to cos phi. V is the here RMS value, and 3.22 is the RMS value of the current and the power factor. Then we found the power consumed. After that we drawn this. You can see this is the I1, angle is 75.14, and this is the I2, and this is positive 75. And then after that we found that main current. Now you can see the length of I is lesser than I1. Therefore, the branch current you can see of higher magnitudes, but the main current is of lower magnitude. That only can be understood from if you draw the vector diagram. And that is all about this problem.